Here is a question that decides whether you can ever add a second server. Same request sent twice. Does your server remember the first one? If the answer is no, your service is stateless. If the answer is yes, it is stateful. That single word decides how you scale, what happens when a machine dies, and why some systems heal themselves while others page you at 3 in the morning. Let's walk through the actual code, both ways.
First, what is state? State is anything your server remembers about you between two requests. You logged in a minute ago. Your shopping cart has 3 items in it. That memory has to live somewhere. And the whole stateless versus stateful question is really just one question. Where? Is it inside the server's own memory, or is it carried along with every request and kept somewhere every server can reach? Everything else follows from that choice.
Here's the server almost everyone builds first. At the top, a plain dictionary called sessions. When you log in, the server makes a random ID, stores your user and an empty cart in that dictionary, and hands you the ID. From then on, you just send the ID back, and the server looks you up. Now notice what that dictionary is. It is the state, and it lives in the memory of this one process on this one machine. That detail seems harmless today. It is the whole story.
Because one day, traffic grows, and you add a second server. Now a load balancer sits in front. That is the machine that spreads incoming requests across your servers. And here is the trap. The load balancer has no idea that your session lives in server A's memory. It just picks a server. Nothing in your code is wrong. The architecture is. Watch it fail. Your first request lands on node A. It logs you in and stores your session in its dictionary. Your second request, same user, same session ID, lands on node B. Node B looks in its own dictionary and finds nothing. You are logged out. Your cart is empty. Nothing crashed. No error was logged anywhere. The state was real. It was just standing in the wrong room. There is a quick fix, and you have probably seen it. Sticky sessions. You tell the load balancer, hash the client's address, and send the same person to the same node every time. 2 lines of configuration, and the bug disappears. But look at what you gave up. The load balancer used to route by who is free. Now it routes by who you are. And your session still lives in exactly one machine's memory. So play it forward. 4 nodes and every user is pinned to one of them. Then node A dies. A deploy, a crash, a bad disk. Every user pinned to node A is logged out at the same moment, carts and all. 1/4 of your users gone in 1 second. And you cannot take a busy node down for maintenance either, because its memory is the product. Sticky sessions did not solve the problem. They postponed it. So flip the whole idea. Stop making the server remember. Make every request carry everything the server needs, who you are, and signed proof of it. Then it does not matter which server answers, because no server holds anything about you. That is all stateless means. The memory did not disappear. It moved into the request itself. Here is what that looks like in code. At login, instead of storing a session, the server writes a small note. This is user so-and-so, valid for 1 hour. Then it signs the note with a secret key and hands it to the client. That signed note is a JWT, a JSON Web Token. On every later request, the client sends the token along, and the server just checks the signature. Now look at what is missing. No dictionary, no lookup, nothing stored. Any node that knows the secret can verify the note. And now the failure story runs in reverse. Request 1 lands on node A. Request 2 lands on node D. Both carry the token, so both just work. Node C dies in the middle of the afternoon. The load balancer quietly routes around it, and nobody gets logged out, because nobody's session lived there. Need more capacity? Add a 5th node, and it is useful the moment it boots. This is what it means when people say stateless systems scale out and heal themselves.
But there is one honest catch. A signed token can prove who you are. It should not carry your shopping cart. Tokens travel with every request, so they need to stay small, and you cannot reach out and edit a note the client is already holding. Real state still has to live somewhere, so you push it one step back, into a shared store like Redis. That is a small, fast database that every one of your servers can reach. The cart lives there now, keyed by user. And look at the server. It still remembers nothing. The state did not vanish. It moved somewhere shared.
Here is the arithmetic that decides it. 4 sticky nodes. Lose one, and 1/4 of your users lose everything they were doing. Stateless with a shared store. Lose one, and the number of lost sessions is 0, and adding capacity stops being a project. It is just one more machine behind the load balancer.
So here is the whole picture. Stateful means the server remembers, and that memory pins users to machines. Stateless means the request carries everything, so any machine can answer. But it was never pick one. Real systems go stateless at the edge, where the scaling and the failures live, and stay stateful only where continuity truly demands it, like a live game or an open video stream. Identity goes in the token, state goes in the shared store, and the servers themselves stay disposable.
If that made stateless versus stateful click, hit like and subscribe. I take one concept and walk it all the way down to the code, every time. There is a 90-second version of this in the description if you want the quick recap. Next up, that shared store is now the one thing every server depends on. What happens when it gets slow?